Shirate Gamiga
high school na jiring dikta nahi so sikira ono kasi wai kasam ni high school na den nahi na mon ko ta da ko dimo da
Tadi mila ko mo
mon ko ta da ko diyo cha chani ta Nagi compound microscope so serious atichi gachilo at magnification na mom jono ba ti da ngai thoni je ma ani be yelo na ga ase de same zero me na microscope ra imi ni thera me
tani jam chinde tum
onde an be ni mashi de ya wa chal tu job joge da le jo do ta ma mere mi so ta me
lab could give me झगड़े लड़के को
nara kya goya
लड़के को में अंदर और दुनिया अंदर
Minum, vai. Minum. Show. Juga yang mana?
A few moments later.
Good morning, class.
Good morning, miss.
So sit down.
Thank you, miss.
A few moments later.
Very practical na. Let's get mo zawajin. Ani human cell ni observation tu ka. So kita nak ini sesuatu yang microscope nak ada sendiri. Mari kita lihat sesuatu. Imagine lab में any microscope digara, compound microscope mo. So I hope you guys really know how to use it. Shemo. I guess I did not tell you anything about the procedures and all. The chindi da to thori noto ne mena kara shiro mo share. So ani cell also beni denu microscope re thu bada ga to ba. Ha so
Wah, lagi kena film itu bete. Kena nanti. Saja, sih kita mau bisa. Wah, itu tahu ya. Ya, baca itu.
Oh, just rabi misibe kachin bisi gomu oh ngadi ni thumne gachin nate ya chai ta oi chai mi dan gachin na phi men
왜 체다들이나 치는 걸로 내비냐 왜 마이크로스코프 use betang di 같이 뭐 이다이 토림 로드기 students 수며 왜 책 college students university level 기 next time relation happy show मारे microscopy di उ गमरा गमे चिंता दी ना वे class dismiss दी दा जोदा
A few moments later.
So, what went wrong in that classroom is something many beginners experience. It's not due to the lack of interest, but it's due to the lack of guidance. But every mistake we make is a chance to learn. So today, let's take a step back and start from the very beginning, the right way. Welcome to this tutorial where we will explore the fundamentals of microscopy, from understanding its part to mastering the technique. Let's unlock the microscopic world the right way. So the word microscopy, microscopy. Let us dive into what actually microscopy is. To go with definition, Microscopy is the scientific technique of using a microscope to view objects and structures that are too small to be seen with the naked eye. It allows researchers to observe the fine details of cells, microorganisms, tissues, and other tiny specimens at high magnification. Before we begin, let's get familiar with the parts of a compound microscope. Let us get to understand the microscope from the very beginning. Although there are several parts of a compound microscope, for now let us just look into the basic parts, which is very important for new learners and beginners. So, to go with the very basic yet the most important part of a microscope is first of all the eyepieces, which is also known as ocular lens. The eyepiece is the lens located at the top of the microscope that you look through. It typically has a 10x magnification, meaning it enlarges the image 10 times. The microscopes may have interchangeable eyepieces with different magnifications. The eyepiece works together with the objective lenses to provide the total magnification of the specimen being viewed. Now let's go with the objective lenses. It is located on a rotating nosepiece, also known as turret. These lenses provide the primary magnification. Most compound microscopes have 3 or 4 objectives, and they are, first of all, 4x, which is used for scanning objectives. So it clearly provides an overview of the specimen. Next, 10x, it is for the low power objective. So this is for the general observation. 40x, high power objective, which is for detailed view of smaller structures. And lastly, the 100x, which is used in oil immersion objective, and it is used with immersion oil for ultra high magnification and resolution, often for bacterial or very fine cell detail. So by rotating the nosepiece, you can switch between these lenses as needed during the observation. So now let's go with the stage. The stage is the flat platform where you place your prepared slide. It usually has metal clips or a mechanical stage to hold the slide securely in place. Many stages are equipped with adjustment knobs that allow you to move the slide left to right and forward to backward, enabling precise positioning under the lens. Now let's go with the curves and fine adjustment knobs. These knobs are used to focus the image of the specimen. So the coarse adjustment knobs, it moves the stage up and down quickly and is used only with low power objectives such as 4x or 10x to bring the specimen into rough focus. The fine adjustment knob, it moves the stage slightly to sharpen the focus, especially when using high power objectives, 40x or 100x. This prevents damage to the slide and lens while allowing clearer detail. So lastly, the light source or the illumination. The light source, which is usually located at the microscope's base, it illuminates the specimen so that it can be clearly viewed through the lenses. It may be a halogen lamp or an LED, and its intensity can often be adjusted. Light passes through a condenser lens and diaphragm, which help focus and control the light beam onto the slide, enhancing contrast and visibility of the specimen.
Before using a microscope, it's essential to set up correctly to ensure an accurate result and to protect the delicate components. Let's break this process into a simple step you should always follow. Step 1. Place the microscope on a stable surface. Begin by carefully carrying a microscope with both the hands, one firmly holding the arms and other supporting the base. This reduces the risk of dropping it. Set it down gently on a flat, clean surface, preferring on a non-slippery lab bench that's not too close to the edge. This prevents vibration and movement during the observation. Step 2. Check the power source and adjust the light. To ensure the microscope is connected securely to a power source, turn on the built-in illumination system. Use light intensity control to increase or to decrease the brightness based on the sample and a magnification level. Too much light can cause glare, while too little can make a specimen hard to see. Adjust the diaphragm as well to fine-tune the contrast. Step 3. Ensure the lenses are clean using a lens paper. Clean optics are key to clear viewing. Gently wipe the eyepiece and objective lenses using a lens paper, a soft, non-abrasive material significantly designed for optics. Avoid using a tissue papers, clothes or your finger as they can leave scratches or oil smudge. If needed, a drop of lens cleaning solution may be used on the paper, not directly on the lens.
Now, let's prepare a sample slide in a right way. This process is essential for getting a clear focus image under the microscope. We will demonstrate it using a sample of animal cells like chick cells. Step 1. Place a drop of water on a clean glass slide. Begin with a clean glass slide to avoid contamination. Using a dropper, place a single drop of distilled water at the center. This will help to spread and support the specimen. Step 2. Add the sample, example, chick cells or onion peel. Collect your sample carefully. This can be a thin layer of onion epidermis or a chick cell smear. Gently place it in a water drop to keep it hydrated and in place. Step 3. Apply a drop of stain, example, methylene blue. To improve visibility, apply a drop of stain such as methylene blue. This helps highlight the cell structures like the nucleus by adding contrast. Avoid using too much stain as it can obscure details. Step 4. Carefully place a cover slip at an angle to avoid air bubbles. Now, hold the cover slip at an angle roughly 45 degrees and slowly lower it onto the sample. This method prevents the formation of air bubbles, which can distort the image under the microscope. Let it settle naturally. And that's it. Your sample slide is now ready to be examined under the microscope.
Now that the microscope is set up, your slide is ready. Let's correctly view the specimen by following these important steps. Step 1. Start with the lowest magnification, 4x. Always begin with the lowest magnification, typically the 4x objective. This provides wider field of view, making it easier to locate the specimen. Step 2. Use the coarse adjustment knob to bring the image into focus. Use the coarse adjustment knob to raise or lower the stage until the specimen begins to come into clear view. Take your time and watch through the eyepiece as the image sharpens. Step 3. Switch to higher magnification, 10x, 40x. Once the specimen is located and roughly focused, switch to higher magnification such as 10x or 40x for more detail. At this stage, use only the fine adjustment knob to sharpen the image, never the coarse knob at high magnification.
Now let us look at some common mistakes to avoid while using microscope. Even with the best tools, results can be inaccurate if proper techniques aren't followed. Let's explore some common mistakes students make and how to avoid them. Mistake number 1. Using the coarse knob at high magnification. Never use the coarse adjustment knob when using high power objectives. This can cause the lens to crash into the slide. Instead, use the fine adjustment knob to make small, precise focus changes. Mistake number 2. Pressing too hard on the cover slip. Applying too much pressure can break the cover slip and damage your sample. Instead, handle slides lightly, use tools like tweezers and drop the cover slip slowly to prevent air bubbles and cracks. Mistake number 3. Cleaning lenses with tissue or fingers. Cleaning lenses with tissue, cloth, or fingers can scratch or smash the glass. Use lens paper only and wipe gently in a circular motion to maintain lens clarity. Final tip is that microscopy requires precision and care. Avoiding these mistakes ensures accurate results and protects your equipment.
A few moments later.
왜 돌지 생각이 왜? 줬어 돌지.
Ela imagine anjumi pani ra मेरो दिदैथिगि त्यति तस्ता लेजुम मेरो थोमे थिए
왜 चालाले सुबिन भाबी जाउनु नि चानिमे दिन.
Microscopy is more than just a classroom technique. It is a window into the invisible world that shapes life itself. With patience, precision, and the right practices, we can explore cells, tissues, and microorganisms in extraordinary detail. Thank you for watching, and remember, every great discovery begins with a single well-focused slide.
This is Group 2 signing off officially. Thank you for watching and do follow and subscribe for more interesting videos.